All right, I'm gonna darken up my lines here. If you want to, it does help to be able to see your lines. All right, troops. So as we go throughout this unit, we're going to be adding vocabulary to this as we go. We're going to start off with quite a bit, though, of vocabulary that we're going to go through. And the first thing, actually, before we get to this, I can't go over your quiz from before break yet because there's some people in here that haven't taken it. So if you have questions about why you missed a problem on the quiz, feel free to come in after school, ask me during class when there's free time, or come in during nutrition break. I'm happy to just show you what you did wrong. Once everyone has taken it, we can go over it as a class, okay? All right, the first term we're going to talk about today is point. Okay. I'm going to demonstrate for you guys and then also demonstrate for the camera for those people that are at home. Okay, so a point. A point is a location in space, okay? So if you think about like the tip of my pencil suspended in space as a point, okay, that's basically just a location. Now, it's important to know that a point in space, it does not have any size, it does not have any shape. It's just a location, okay? And we're used to seeing points in one dimension or two dimensions, like on a piece of paper, but it's important to know that points can be anywhere in space, okay? So let me show you. My goodness, I just had my pen in my hand and now. Good grief. Okay, we're moving on. Okay, so let's write down the definition for a point. A point is a location in space, and a point has no shape or size. Hold on, let me white this out. Maybe. There we go. Okay, so it's basically all it is a location. It does not have a shape. It does not have size. Doesn't have area or volume or any of that, okay? Now, when we are talking about a point on a piece of paper, we just use a little dot, and we name it with a capital letter. So we can call this dot, or this point A, and then maybe there's another point over here, which we'll call point B. We typically use capital letters to describe a point. Okay. Well, that's a point. Now, let's talk about lines. Okay. Lines, where's my pen I was looking for? That could have given me a heads up about that. Okay, a line is, it goes on infinitely, forever and ever, in both directions, and it never stops, and it has no thickness. So if we imagine this line in space right here, going on forever infinitely in that direction, and forever infinitely in this direction, and never stopping, that is a line. Okay, my pen has thickness to it, and it's only a part of a line. But a true line goes on forever and has no thickness. Okay, and what we say quick definition for line. So a line is a straight, continuous arrangement of an infinite number of points. And it's important to know that a line has an infinite length and no width. Okay, so let's go ahead and show what this looks like in 2 dimensions on a piece of paper. When we're talking about a line, we need to make sure that we have arrows on both ends of those lines. Just like we would when you guys were doing graphing of lines, y equals mx plus b. Those lines go on continuously, forever, infinitely in both directions, which is why we always put arrows at the end of them. Same thing is true with our line here. Now, a line can have a 1-letter name. We typically use a lowercase italicized letter. So in this case, this would be line M. That would be the name of that line. So sometimes it's described with a letter. Sometimes we put a couple points on that line to give it a name. So here's another line. We know it's a line because there are arrows on both ends. And I'm going to put 2 points on here. This is C, D. So we would call this line M here. Well, with this line, we can name it like using the points. So we can call this line CD. Now notice that I put a little line above it, the C and the D, with little arrows to show that that is a line. It is line CD. Now, the order of the points doesn't matter. We can also call this line DC. And it is describing the same line. And if I put a 3rd point on there, like a point E, then that line could be called CE or ED or DE. It doesn't matter. It's all referring to the same line. Okay? All right. So that's a line. It's a continuous, straight arrangement of an infinite number of points. Now let's talk about a plane. Not the kind of plane you fly on, but like the surface, okay? For instance, my plastic barrier here that's supposed to protect me from COVID, I really don't think it does very much. But this would be considered a portion of a plane, because it doesn't go on infinitely like a plane actually does. This is just a portion of it. But if you imagine this going on infinitely in all directions, through the ground, off infinitely that way, up into the space this way, that is a true plane. Never ends. It goes in all directions infinitely. And we would say it has no thickness to it. Yeah?
I thought plane was spelled P-L-A-I-N.
Well, I think this type of plane is P-L-A-N. But honestly, like, spelling is not my strong suit. So you might be right about that. And I could be wrong. I think the plane you're thinking of is like plain yogurt. You know, like no flavor. Plain.
Yeah, nothing wrong.
Yeah. You're right. So a plane is a flat surface it has infinite length and width, but no depth. Or you could say thickness, no thickness, okay? Now, it's really hard to, on a two-dimensional piece of paper, describe visually something that is typically in 3 dimensions and goes on infinitely forever. So the way that we usually draw out a plane is using a parallelogram. I honestly cannot remember at what stage in math we did this, but I remember graphing planes on a 3-dimensional plane, coordinate plane. Coordinate, I don't know, it wouldn't really be considered a plane if it's not a plane. Now to name a plane, we just put an uppercase italicized letter on that plane. So that plane would be considered plane Q. Plane Q. It doesn't have to be Q. You could name it P, plane P, or plane R, whatever you'd like.
You have 26 options.
Yeah. Okay. The next thing we're going to talk about is a line segment. It's exactly like it sounds. It is just a part of a line. So for instance, we're going to pretend my pen is a line segment. A line segment has two inputs, okay? Here and here for my pen. And it has infinitely many points in between them as well. Okay, so a line segment is just a part of a line, and it has 2 endpoints. So let's write the definition for that. It is a portion of a line that includes 2 endpoints and all the points between. Them. Okay. And when we draw a line segment, we don't put arrows because it doesn't go on infinitely like a line does. But we do put endpoints. So here's an endpoint, and here's an endpoint. And we're going to give those endpoints names. So we'll call this A and B. Now when we are referring to a line segment, we write it just like we would for a line, except we do not put arrows on that line. So we could call this line segment AB, and we know that it's a line segment because it does not have arrows. We can also refer to this line segment as BA because it doesn't matter the order. Oh my goodness, you guys are so easily distracted. Okay. Or easily amused, maybe is the better word. Okay. Now, like a book, if you were reading a book, you'd be reading, and then you'd turn the page and you would start reading from over here. So this is where we're going to pick up. open it.
To the right or left?
The part that you were just looking at. So like this, and then right here. So top left corner is where we're gonna start. Yes, ma'am. Yeah, it's the vocab foldable, page 2. You're welcome. All right, guys, let's go on. Now, I typically do a whole week of using a compass and a straight edge. But because of lovely, not so lovely COVID, we just don't have time because I had to go a little slower during distance learning. So I will be demonstrating some things with a compass, but we are not going to take the time to learn how to construct figures with compasses. Okay. I know it is sad. I agree. It's like one of my favorite things, but anyways. All right, so the next thing that we're going to talk about is an arc, which you guys are actually kind of familiar with because in the last unit we were finding the length of arcs, which would be a partial circumference of a circle. Okay, so an arc is the curve between 2 points. So let me show you what this looks like. You're going to have to freehand it if you don't have a compass, which is fine. Okay. So it's basically like a part of a circle, but it has endpoints. So we'll call this point C and this point D. And when we are referring to an arc, we write out arc CD. That is how we write the name of an arc, arc CD. Or arc DC, that's true. All right. Our next term is called a ray. Now, I'm going to demonstrate for you using my pen. A line goes on infinitely in both directions. A ray only goes infinitely in one direction, and it has an endpoint. Okay, so a ray has an endpoint, and then it goes continually on forever and ever and ever in one direction. So it is a part of a line that begins at a point and extends infinitely in one direction. Okay? So let me draw this for you. So a ray has an endpoint, and then it goes on infinitely in one direction, like this. Okay? So that's what a ray looks like when we draw it on a piece of paper. And we need to name this ray. And the way that you name a ray is you give the endpoint a name. So this is A. And then you put another point somewhere on that ray, and we'll call this one B. So if we're referring to this ray, it looks like this. Okay, so notice that the arrow is only on one side, not both. And you also want to be consistent. If the ray is going from A to B and on infinitely, then your arrow should be pointing that way. you need to flip the arrow then on top, so that we know which one is the endpoint and which one is showing the direction of the ray. Okay. So that's a ray. And then the last thing we're going to talk about is an angle. An angle is two rays that share an endpoint. So if we share an endpoint with these two pens, this would be like an acute angle. It has an endpoint and a ray and a ray. You could do a 45-degree angle, so a right angle. They all share endpoints. You can have an obtuse angle, you could have a straight angle. These are all considered angles because they share an endpoint and they have two rays that go on infinitely forever and ever and ever. And they never stop. Okay? So an angle is formed by two rays that share a common endpoint. Okay. Now, we'll finish this definition and how to name angles tomorrow. I want to make sure everyone has time to clip in their binder their vocabulary foldable. So you should have your table of contents, your assignment sheet, and your vocab foldable. So no